Covering graphs of sine, cosine and tangent. And we will first work on sine, later on we'll compare it with cos and tangent. That is easier to understand. So let's get started. These are the graphs. At a later stage we will also study transformation of these graphs. Yes. Sure. Graph of sine theta. Y-axis, x-axis, and sine is 1. It lies, the range is 1 and minus 1. Graph of sine will look like this. We will do it in two ways, in degrees and with radians. So this is 360 degrees and you uniformly split them. This becomes 180, this is 270, and this right here is 90. So this is graph of sine theta. Ultimately our ultimate goal is a sine b theta plus c. This is the second last stage and I'll introduce to you with the last stage later on. So A is the amplitude, B is number of cycles, in 360, and when we will solve it for radians, it will be in 2 pi. 360 is equals to 2 pi radian. If we are dealing in degrees, it is 360, in radians it is 2 pi radians. And C is the displacement. So let's deal with A first. If I have A sine theta, we already know that the graph of sine theta looks like this. The shape looks like this. It ends at 360. The midpoint is 180. This is 270 and this is 90. So this will be A and this will be minus A. In our first case, it was 1 sine theta, so it was 1 and minus 1. So what if we need to draw 3 sine theta? Now be careful when you compare these three. We're done with two graphs and I'm drawing the third graph. When you compare these three, these are not on the same scale. So this is 360 right here. The highest value is 3, the lowest value is minus 3, 180, this is 90, and this is 270. If you draw this all on one axis, they will definitely be in a shape that you can compare them. For example, if I draw sine theta on this and I show you it in this way, this is 360, it ends at 360, the highest value is 1, the lowest value is minus 1. Then we draw 2 sine theta. The only difference is for amplitude. So in green it is twice that. The shape is not changing, the curves are the same, but now it lies between 2 and minus 2. Third graph, if we draw 3 sine theta, so amplitude would be 3, it passes through 0 from the same points, ends at 360, so this is 3 and this is minus 3. Is the role of A clear? A sine theta, A is the amplitude. What if we change the value of A with a negative number? For example, I say minus 2 sine theta. So rough working is, we know that sine graph looks like this, but when you multiply it with negative number, all of the values, they switch. Positive values will become negative and negative will become positive. So this is how it will look like, and we know that the amplitude is 2. So when you have to sketch it neat, it will look like this. Because of the negative number, it is inverted, it still ends at 360, the midpoint is at 180, this is 90, this is 270, and the amplitude is still 2 and minus 2. 2 and minus 2. Because of this negative number, it is switched. So are we clear with A sine theta? Are we clear with this A, first part? Any confusion? Okay, so now let us introduce B. We're done with A sine theta. Now I'm doing A sine B theta. To understand B, we will just skip this A for now. So if I have like sine theta, if I talk about B here is actually 1. So sine theta will look like this. This is 1, this is minus 1, this is 360, and it is equally divided, making it 180, 90 and 270 again. So what will the graph of sine 2 theta look like? Coming back to this, we discussed that A is the amplitude, B is the number of cycles in 360 or 2 pi. 360 or 2 pi. Now this is 2. So that means we will have 2 cycles in 360. So this is my first cycle. This is my second cycle. So in 360 I have 2 cycles. Now we equally divide them. This is 90. This is 270. The amplitude is still 1 because of this 1. And this is minus 1. So sine theta and sine 2 theta, this is the difference. And let's just plug in what it would be marked when we do it in radians. This is 90, this is 270. This is the only difference. Yes. Yes. Exactly the same. Yeah, exactly the same. It is exactly the same for A sine B theta plus C. If you remember that, we can do it like quickly. Yes, it is the same concept. We will merge these two topics with transformation. Sketching of trigonometric ratios with transformation. Our very next topic is transformation. That is what happens when you multiply with 2 or would divide with 2. So that's transformation. So that means we are done with B as well. So we know sine B theta. Now we are introducing C. And for now we skip A and B, or we say that A is 1 and B is 1 to understand C, and then we will bring them all in one graph. So A sine B theta plus C, for now we are taking A is equal to 1, B is equal to 1, and we will change C to understand. If I draw sine theta, this will look like this. And sine theta will be 1, minus 1 and 360 or 2 pi. But what happens when we draw sine theta plus 1? This plus 1 actually means the whole graph is going to move 1 unit upwards. So this point at 0 raises here, this point at 1 raises at 2, this point at 0 raises at 1, minus 1 raises at 0, 0 raises at 1. You add 1 to every value, and this is your new graph. This is your new sketch. This is sine theta plus 1, and do not forget to label. This becomes 2, this is 1, that was 0, 360 is at its place, and this is exactly about 180, and this point is about 90 and 270. So this is C. If you add something, it moves up. If you subtract something, it moves down. Now there's a strategy. We have two options. One is we move the curve upwards, or we move this x-axis downwards. moving x-axis downwards is easy. For example, if I draw sine theta, this is sine theta, and I'm doing it with pencil, so I can erase and remove. So if this is sine theta, I know that this was 0, this was 1, this was minus 1, and I know that sine theta plus 1. I have to move this graph 1 unit upwards. What if I don't move this graph 1 unit upwards and bring this line 1 unit below? So drawing or moving this line is easier. So if I bring this line down and I use my eraser to remove this and the lines and mark them new 0, 1, 2. Now look at this. The highest point was at 2, it is still at 2. The lowest point was at 0, the lowest point was at 0, it is still at 0. This is 360. This turning point is 180, 90 and 270. So it is quick to move the x-axis. Let's do one more question quickly. Let me start this again, it's getting a bit stuck. Okay. Now if I have to draw sine theta plus 2, sine theta plus 2. So I'm not drawing the x-axis and I'm considering that I start from this point and we draw sine theta like this. So plus 2, this was supposed to be 0, but when we add plus 2, this was supposed to move 2 units upwards, or the line is coming 2 units downwards at this point. So I'm labeling this point as 0, this is 1, this point is 2, this point is 3. Now the end point is 360, the midpoint is 180. So it is easier to move the line rather drawing a new sketch. Just to compare, if we had this sine theta plus 2 means from 0 it will move 2 units, from 1 it will move 2 units, from 0 again it moves 2 units. And new graph will look like this. So see, compare these two, green and red, they would appear the same if you move the graph or you move the x-axis up and down. Now let's combine two of these. If I draw 2 sine 3 theta, now 2 is the amplitude and 3 is the number of cycles in 360. So x-axis, y-axis, if I draw this is 1 cycle, this is second cycle, this is the third cycle. So we know that it ends at 360, and dividing 360 by 3, it is 120 and 240. You can still divide all the sections and label them. This is 2, this is minus 2. So it is graph of 2 sine 360 for within 360, from 0 degrees to 360 degrees. Now the questions will have a domain. The values of x or the angle are known as domain. For example, the examiner tells you that draw the graph of sine 3 theta for how much? It tells you to draw it from 0 to 180. So first we move for rough sketch. Once you have practiced it, you can draw it directly. So 3 theta would mean you should have 3 cycles in 360. So having done with the first cycle, I know that it is 120 because 360 divided by 3, one cycle completes in 120. Now I know that I have to complete it till 180. If I am not confident, if I practiced it less, I'll draw it completely. I know that this is 240. Now we know 120 and 240, the half of this is actually 180. So I should have stopped here. So I will use the eraser and my final graph will look like this. This is one cycle, this is another half of the cycle. So this is 180, 120, 60, 30, 90, 150 and the amplitude is 1 and -1. Is it clear till now? Yeah. For example, I'm coming back to this question. For example, we have this question 2 sine theta, and the examiner tells you to draw this for 0 to 120, so you stop right here. You don't need to go further. If examiner tells you to draw it from 0 to 180, so you stop right here and you do not need to draw it further. For example, the examiner tells you to draw it from 0 to 240. So for 0 to 240, you will stop right here and you will be seeing two graphs, and you don't need to draw 3 till 360. Then there are, yes, sine 30 Sine 30 is one fixed numerical value. Sine 30 is one fixed numerical value. This is theta, angle, unknown angle. That is sine 3 theta, sine 3 theta. So that means you have to draw 3 cycles in 2 pi or 360. Sine 30 is one discrete value. For example, this is 30. So whatever value at 30 it would have in the graph of sine theta. So this was 90, so this is 30. At 30 you will have this value. If you use your calculator, you will get this numerical value. Now we are going to do it with all 3 values. For example, we have 3 sine 2 theta. Let's do it with a negative number. 2 theta minus 1. 3 sine 2 theta minus 1. We know that the amplitude will be 3. There will be 2 cycles in 360 and whole of the graph will move 1 unit down. So first, a rough sketch. This is x and y axis. It is 3. So 1, 2, 3. 1, 2, 3. This. 2 theta means we have 2 cycles in 360. 2 cycles in 360. From 0 to 360. If we draw from 0 to 360, you should show it having 3 cycles. So till now, it is 3 sine 2 theta, and we haven't drawn minus 1. It is 3 sine 2 theta. How it is 3? The amplitude is 3 and minus 3, and there are 2 curves in 360. Now for minus 1, you either move whole of this graph by 1 unit, or you move the x-axis down. You move whole of this graph down by 1 unit, or move the x-axis upwards. So either you move all of the graph, which is a little hasty, so I choose to raise this x-axis by 1 unit. So if I raise this actually looks like the graph is sliding down. So if it is moved 1 unit upwards, we need to change these values and remove this previous axis. So we know this is 0, this is 1, this is 2, minus 1, minus 2, minus 3, minus 4. We knew that the amplitude was 3, right? So from 3 till minus 3, the graph lied from 3 to minus 3. And this negative sign will bring this graph down. So this 3 will go to 2, and this minus 3 will go to minus 4. See for yourself, do you see this 2 and minus 4 right here? 2 and minus 4. So the graph actually slided downwards. For our ease, we lifted the x-axis, and then you label this point as 360, and you know you completed your second graph at this point. So this is 180, this is the turning point, again 90, another turning point, so this was 270. don't have to go in very much detailed labeling. If you wish, you can always use your calculator and find the midpoints. Now from the sketch or without the sketch, you can always tell the range. For example, this very graph, the range of it is, let us call it f of x. If I say f of theta, because I've used theta, let us call it f of theta. If we use f of theta, so f of theta actually lies between minus 4 and 2. This is the range. It lies between minus 4 and 2. New example, if we have 7 sine theta, I know it will lie between minus 7 and 7. If the question is 7 sine theta plus 2, if we need to sketch it, we know that it will be from 7 minus 7 and then we'll add 2 to each, and this will become 9 and this will become minus 5. So whatever it is always 7 plus 2, because plus 2 is raising it. The upper value is already 7, the amplitude was 7, so 7 plus 2 is 9 and less than equal to sine theta plus 2, which is less than equal to the lowest value was supposed to be minus 7. When you add it 2, it becomes minus 5. So this is the range. Yes, we are just like getting examples that how do we directly tell the range. For example, the question is 12 sine theta, so I know that it will lie between 12 and minus 12, right? So this will be the range. If the question is 12 sine theta minus 3, now the highest value which was supposed to be plus 12 and lowest which was supposed to be minus 12, because of this minus 3 everything is coming down. So 12 minus 3 is 9 and minus 12 minus 3 is minus 15. So this is the range. If you sketch this graph, 12 sine minus 3, 12 sine theta minus 3, it will look like this. Let me get rid of this. This is a sketch of sine, and the highest value which was supposed to be 12 and minus 12, because of this minus 3, both of these are reduced by 3. So these will be 9 and minus 15. And it would look like this. Is it clear? Sine theta. A quick revision before we move on to cos. A sine b theta plus c. A is the amplitude. So if we have 4 sine theta, we know it will be plus 4 and minus 4. And b was number of cycles. If we have sine 4 theta, we know that there will be 4 cycles. 1, 2, 3, 4 cycles in 360. But if the examiner tells you to draw the graph for 0 to 180 only, we know that from 0 through 360 there will be 4 cycles, and if we have to draw for 180, this is half of the domain, so there will be only 2 cycles, 1 and 2, and this is still the graph of sine 4 theta because we are drawing till 180. If we complete it till 360, we will see 4 cycles. And C is the translation. If it is positive, graph moves upwards. If it is negative, graph moves downwards. This is sine theta. If we draw sine theta plus 1, we move all of the graph 1 unit upwards. If we draw sine theta minus 1, we move all of the graph 1 units downwards, or we play with the x-axis. It entirely depends on your comfort. Now everything stays the same for cos except the shape. All the concept is same except the shape of the graph. This is the shape of cos, and this was the shape of sine. So everything stays same. This is cos theta. I've written cos theta, so this is now supposed to be 1, and minus 1. For sine theta, this was again 1 and minus 1. It ends at 2 pi, it ends at 360. If you are doing it in degrees, it is 360. If you are doing it in radians, it is 2 pi. Now this is cos theta. So let us quickly draw this. If we draw 2 cos theta, the shape stays the same. This is plus 2, this is minus 2, it ends at 2 pi. The midpoint must be pi. If you need to continue, this is pi by 2 and this is 3 by 2 pi. In form of degrees, it would have been 180, 360, this is 90 and this is 270. So A sine theta, this is A cos theta. So amplitude, we play with this amplitude. For example, I change this right here with 12 cos theta. So this will become 12, this will become minus 12. If I change this same with 120 cos theta, so this is 120 and this is 120. So the shape stays the same and we just play with the amplitude. So done with A, let's do with B. So for cos theta, in this case, B is 1. So this sketch looks like this. It ends at 2 pi, 1 minus 1. But what if we do cos 2 theta? Now 2 means we will be looking at 2 cycles within 2 pi. So this is 1 cycle and this is another cycle, 2 cycles in 2 pi. So this is cos 2 theta. If I draw the graph like this and label it pi, this is still cos 2 pi. Why? Because we know that 2 theta means we will be looking at 2 cycles in 2 pi. So that would be 1 cycle in pi. So this is still cos 2 pi. If I still draw the graph for 0 to pi by 2, which actually means 0 to 90 degrees. If I draw this graph for what? I draw the graph for cos 2 theta. So before drawing, because we have done much practice and if we understand, we can directly draw it. If I need to draw it directly, cos 2 theta would mean, a rough sketch is that I should look at 2 curves in 2 pi, but the examiner tells me to draw it for pi by 2. So I see that half of 2 pi is pi, pi by 2 will be ended here. So ending it here, my graph should look like this, and I stop at pi by 2, and now I label 1 and minus 1 because the amplitude is still 1. So for example, we draw for cos 2 theta, again 2 theta, but now we draw it from 0 to 270. This all depends on your practice. There are 2 ways. You can draw the graph fully till 360 and then erase it, or you first calculate in your mind and then solve. So I'm drawing for someone who has less practice. So this 2 theta means I will be looking at two cycles. This is the first cycle and then the second cycle. Now I know that this will be 360, this is 180, midpoint of these two is 270. So now we know that our graph should have stopped right here. So for cos 2 theta, but for the given domain 0 to 270, for cos 2 theta, this is one complete cycle till 180, and then for 270, half of the cycle. So it ends here. This is our final answer, and the amplitude is 1. But what if I write 7 cos 2 theta and still draw it from 0 to 270? So now the amplitude is 7 and minus 7 and makes no difference to the number of cycles in 270. Are you getting it? It can tell you to draw it up to any value, reasonable value, 180. This is 2 theta, 2 theta. 2 theta means 2 cycles. If theta is getting confusing, we can write x. 2x. 2x means 2 cycles in 360. Theta is the angle. Yes. Yes. Pi is equals to 180. 2 pi is equals to 360. Radian. Pi radians. 2 pi radians is equal to 360. We're done with A, we're done with B. Let's try C. So cos theta plus 1. If it would have been cos theta, the graph will look like this. For plus 1, we raise the graph by 1 unit. Or if this is cos, or we drop the x-axis by 1 unit. Both are same. Examiner is interested in the final answer. So again, if we have 2 cos 3 theta plus 1, before we sketch, we know the amplitude will be 2, so it should range from 2 plus 2 to minus 2, but this plus 1 is lifting the graph 1 units upwards, so this becomes plus 3 and this becomes minus 1. Now we know that the graph ranges from plus 3 and minus 1. So we start the graph from anywhere, keeping this symmetry of the graph. I'm using these 4 lines and this. I'm completing it in 4 lines. So it should range from 3 to minus 1. This is 3, 2, 1, 0, minus 1, and what did we do? Let me count 1, 2, 3, 4, 5. Keeping it in 4 lines. Let me check. Just give me a minute. So this is 3 and this is minus 1, 2, 1, 0. So now at our 0 we can draw this. Okay, Mohammed, this is 3. 3 meant that this was supposed to have 3 cycles in 360, means 120 degrees it will be 1 cycle. So this 1 cycle completes at 120. So now this point is 60 and the point where it converges, this is 30 and this is 90. It should have passed from 30 if there was, this one was missing. Clear? Okay, that's what at least you understood. So this actually depends on your practice. This actually depends. Now we have already drawn this graph, so we can see that the range is 3 and minus 1. It lies from minus 1 to 3. Sometimes the examiner tells you for 1 mark that you're given with the question, so I'm replicating this with different values. If I say this is 12 cos 3 theta, or let me say 35x, 35 cycles, so it has nothing to do with the range, so I don't have to worry. Plus 5. So this 12 was supposed to mean that it should range from 12 to minus 12, but plus 5 means this 12 raised by 5, 17, and minus 12 plus 5 would mean minus 7. So it lies between minus 7 and 17. So this is how you tell the range directly. Domain is always given in the question. Now there is last part which we skipped. That was a sine b theta plus c. This was a sine b theta plus c. Now I'm introducing another number and writing it as, suppose, sine x plus d or sine x minus d. Now this plus d and minus d, a was the amplitude, b was the number of cycles in 360, c means the displacement, the graph moves upwards or downwards. This d right here would mean that the graph moves left or right. If it is positive, the graph moves left. If it is negative, the graph moves right. For example, we have sine of x. Sine of x, if we have sine of x, this is the case. It ends at 360. This is 180. I need a detailed labeling because I want to sketch it, move it horizontally. So suppose I do sine of x minus 30. This negative means it will move towards the right. So all of the graph moves 30 degrees to right. So this is 30 degrees to right. We just move the main points and sketch a new graph. So this new one is sine x minus 30. So these are the complete variables: a sine bx minus d or plus d plus c. So these are the functions of a, b, c and d. For sine and cos, we're left with tan. Tan is a little different because the sketches are different. Have you done a graph of tan in IGCSE O levels? Right, so this is the asymptote, and yeah, that's it. So this is the graph of tan. Now this is 360, this is 180, this is 0. It has nothing on the y-axis. For example, I say this is the graph of tan theta, it is true. If I say this is graph of 2 tan theta, this is still true. If I say this is graph of 13 tan theta, this is still true. The only thing which will change it is horizontal shift or vertical shift. For example, tan theta plus 1. Now you'll understand the urge that I want you to move the x-axis. For example, you have tan theta already. So this is tan theta. Do not forget to draw this dotted line. This helps you to keep it away from the previous line and make it look like an asymptote. So this is tan theta. Yes. It never touches 90. It never touches 270. No, it never touches it. Try it if you use tan 89.9 in your calculator. Then just keep raising it, but don't write 90. At 90, it will give you math error. Before that, the value will keep on increasing to a very large value. Yeah. Suppose you have tan theta. This graph is already for tan theta. Now plus 1. Moving this complete graph upwards is hectic. If I have to move this, so 1, 2, 3 and keeping it neat would be hectic. But plus 1 means you have to move the graph upwards or bring the x-axis down by 1 unit. So I've just drawn a horizontal line and erased the previous line. Look, tada, you have it. So tan theta plus 1. Either you shift the graph by 1 unit or you bring the x-axis down by 1 unit. And again, there is no restriction. Whatever suits you, it depends on your practice. Any questions till now for sketching? Whatever is in part of your syllabus is sine theta, cos theta, tan theta sketching, first part. Second part, range of it. So there is no range for tan, only for sine and cos, and it is always the amplitude positive value, negative value first. Second, if you have a shift, we definitely incorporate that. And thirdly, last thing would be transformation, which we indirectly discussed. If like the examiner may ask you, explain the transformation, he may tell you sine x first graph and second is sine x plus 3. So you will say it is a translation of x0 y3. So what happens when he tells you that sine x was the first graph and the second is sine x plus 30, you will tell that the graph is moving towards left by 30 units. So this is the transformation. And yes, what you were saying, from f of x to f of x, this changes the amplitude. Writing sine cos makes it better in understanding. Suppose you had sine 2x, now you had 2 sine x. So what is the transformation? It is a shift a long y-axis, or you can say it is a stretch, sorry, not shift, stretch. It is a stretch along y-axis, or you can say a vertical stretch with magnitude or scale factor 2, because sine x was this and 2 sine x is this. So there's no horizontal shift, there's only vertical stretch. Getting the point? So let's have a quick look at the book. You have the solved examples. For this very exercise, I would suggest you that go through these solved examples first, because you have the sketch there, you can read the question, you can see the final answer as well. So first see what your mind tells you, and does it look like this same? This is sine theta, so see, this is from 0 to 360, and if we continue to right hand side and left hand side, the wave just continues. But in exam you will definitely have a domain that draw the graph from 0 to 180 or 0 to 270, so that is the point where you stop. If your practice is less, you will first sketch the complete diagram and then erase the extra part. Cos theta, again same for sine theta, then cos theta. This is tan theta. Now look at this. By just looking at this, it's already written, but this is the shape of cos and it completes at 360. So this is cos theta. Now look at the first domain. It says draw it from minus 360 to 360. So one cycle is on positive side, one cycle is on negative side. If the examiner would have told you that draw it from minus 180 to positive 180, you sketch this, but you stop right here and you stop right here. This is the only part which you will draw. So go through them, do few sketches, and we'll discuss the problems if you face any. With negative tan, again this is just the shift. Positive becomes negative, negative becomes positive, or you can say it is the reflection in x-axis. Is the concept clear? Okay, so in this case, whatever the question is asking, I'm interested to discuss the range. This is sine, it is supposed to be plus 1 minus 1. Plus 3 means this raises by 3, 4, this raises by 3 is 2, so the range is 4, 2. Highest value, lowest value is the range. Now whatever this is, but this means the tan graph is moving to right by 90 degrees. Again, shifting the graph is difficult, but shifting the axis is very easy. Now you see this graph, whatever the question is, you see this graph, we can say that it is not a perfect sine curve or a perfect cos curve. Now the graph tells you that it is a cos curve. Cos curve should have started from this point, but this is the highest point, so we know this is the shift. This is the shift. Some angle has been added in x, so it is plus 30. If we would be having a grid, we can also count that what shift was there. So please go through, this is just one single exercise. 9G. First go through the solved examples and then 9G, and inshallah we'll discuss the problems. Anything you would like to ask?